So, like I was introduced, I'm going to be talking to you about reproducible performance optimization pipelines with Spack and Ramble. There are some interesting things about this talk relative to other talks so far about things that we do with Spack, which I'll talk about. Some of the graphs are going to be hard to follow if you can't see, but I'm going to talk to you about my team's workflow and some of the tools that we use, and then how we use Spack at Google, and how we do performance optimization. So my team, that doesn't look like my slides. My team at Google focuses on performance optimization of HPC applications. We do benchmarking of customer workloads as part of effectively RFPs in the cloud. We also do collection of data on new systems to try to help understand what market segments different systems are good for. And then the third thing that we do, which is most relevant here, is we develop tooling that helps support those and makes us more productive and efficient. So my next two slides, which I'm looking at but you can't see, are the workflow that we use. So it's going to be kind of hard to follow, but I can summarize them, I guess. So we have what I would guess most of you would be able to visualize in your head as a performance optimization loop for applications, where we do things like decide an experiment we want to run, install everything, download the inputs, get the experiments all ready, run it, look at the output, and decide if we want to keep going or not. I think that's pretty common, depending on what you want to do, whether it's optimization or even just science. And then we have tools that we overlay on different parts of this. So since I'm at Google, we use Google's cluster toolkit for, yay. So here's the fun chart that I was showing you. This is what we do. This is laying tools over it. So we use cluster toolkit for describing our infrastructure. Then most of the experiment workflow is driven by Ramble, which I'm going to talk to you about. And then installing software and dependencies is handled by Spack. This is cluster toolkit. I'm not going to talk to you guys much about it, but the key point is that this lets us have reproducible infrastructure. It's infrastructure code that uses Terraform to deploy different resources. Then we use Spack to install the software, which gives us reproducible software. And then finally, we use Ramble, which describes the experiments we want to use, and that gives us reproducible experiments. Some about our uses of Spack at Google. We have external customer use cases. We provide a Spack cache that helps customers use software that we recommend on our systems. Some interesting differences of this versus the public Spack cache is that we build it on our own images, which aren't super interesting for general purpose. And we try to optimize for our underlying architectures that we offer to customers. And we also try to give Spack environments to customers to help them replicate the performance that we are able to achieve when we run their workloads. So those are things that we try to use this for. Internally, we have an internal Spack package repo that we use to build customer applications that are maybe proprietary and can't be shared publicly, or some ISV apps that don't exist in Spack right now. And it helps us share these more as a team to describe how to install them without having to write a doc that we follow instructions for every time. We have an internal Git repository that lets us store environment configs and some of the things that we would use to build up experiments that I'll talk about in a minute. We also create internal build caches that we use for this, which is kind of like the CVMFS that Mike was talking about yesterday, but just a Spack-based one. That was Spack-based, but a Spack build cache-based one. And then we just installed a bunch of times. And then we mostly use Spack to manipulate the software stack for the experiments so that we can try to do different optimization techniques and see what impact that has on the run. And then the last thing, which is the different thing that nobody has really talked about right now, is that we built new tools using Spack's infrastructure to do different things. So now I'm going to talk about Spack and Ramble. What is Ramble? Ramble's written in Python. It's heavily based on Spack. We actually took Spack's infrastructure, not Spack itself. I mean, we use Spack, but we took Spack's like repository logic and configuration logic and utilities and wrote a different tool based on that. And the goal is to allow us to run experiments instead of building software. So like I said on the next bullet, Ramble is to running experiments like Spack is to building software. And then Ramble provides a flexible templating engine, a domain-specific language for describing how you set up experiments, and standardized definitions for how they're configured and executed. And hopefully this sounds a little familiar to everybody, given that you are all familiar with Spack. Spack has a DSL as well for describing how you install software. This is a high-level workflow in Ramble and how you would use it. We have a concept of workspaces. I'm happy to talk about any of these. I don't think I'll go into super detail with any of these things except for maybe the configure. Anyway, you create a workspace, which is a self-contained directory that describes the experiments you want to run. They could be related. You could make different ones for different apps. It's up to you. It could be like a suite of experiments that you're running. You configure the workspace, which is tell it what experiments you actually want to run, and some template files, which are like stub scripts that it's going to create for you to actually run the experiment. You set up the workspace, which handles installing software, downloading inputs, creating directories for each of the experiments, and piecing it all together. Then you can run them, and then finally we can analyze them. So each of the application definitions describes things that we call figures of merit, which are arbitrary metrics that you will extract from the experiments. And when you run Workspace Analyze, we'll pull those out and store them for you. We can even upload them to something like a BigQuery database. So the configure experiments bit looks kind of like this. You write a YAML file. Here I'm describing how you can parameterize software definitions. So this describes some WRF experiments. In this case, we're talking about doing a scaling study on some different partitions in a Slurm cluster. And the scaling study goes from 1 to 32 nodes, as you can see here. And then what we want to do in this is add on a parameterization of Intel MPI and OpenMPI so we can see what impact that has on the performance. And so here we describe this experiment on the left, which is MPI partition number of nodes. And we vector define MPI to be Intel MPI and OpenMPI. And then on the right, we define the software specs for Intel MPI, OpenMPI, and WRF. And then we have an environment at the bottom that pieces those together. And then every experiment now has its own Spack environment that has either WRF and Intel MPI or WRF and OpenMPI that it will be used to run these experiments. Some other things that we can do with this are we can easily inject performance analysis tools using a concept that we have called modifiers, which are composable abstractions of things that edit the behavior of the experiment. In this case, I'm injecting Intel APS, which has its own software requirements. It would install vTune. It injects a call to APS in the right place in the experiment run command. It also adds figures of merit that are extracted as part of the report that APS dumps to your directory when you run it. So in this case, this will just add in calling APS and making a report and adding those figures of merit alongside the figures of merit from the application that we track. We can also parameterize package managers. So while we're built off of Spack's infrastructure, there are some interesting experiments that you could imagine wanting to do with different package managers. Some people have talked about Easy as a package manager. There's also pip and Spack, so we support all three of those. We also support environment modules. And so in this now, what I'm showing you is parameterizing Spack and Easy for WRF, assuming that WRF has an Easy spec, which just looks like a module path in this case. So now the different experiments, one will have Spack drive installation and create an environment for it. The other one will do module loads to load the Easy environment that it will then run the experiment with. Okay, so I've talked a lot about this already. I don't even know how long I've been talking, but we standardize the experiment lifecycle with Ramble. We have a bunch of different package managers that we support. We also abstract currently some workflows. We have a Slurm workflow manager and a GKE specific one, but it could be generalized to be more Kubernetes in general. So that allows us to do comparisons of Slurm versus GKE or whatever Kubernetes you want with the same workload as well. We support modifying experiments by injecting changes. We can mirror the inputs and software that are in a workspace that experiments would use. We can also create a build cache from the experiment software stacks. So like I showed you earlier, you could imagine that you could have a bunch of different software packages in one workspace. We can say, take all of the experiments in this and now push all of the software packages to a build cache, and it will do that for every experiment that's in there. Some of the more useful things that we do that are downstream of running experiments is we standardize the experiment output. So kind of regardless of what the experiment outputs for its own results file, we read those in and put them in a standardized format that we can then track, and we can upload it to databases and stuff. Some of the things that Spack does for Ramble, or can do. So like I said earlier, we're based off of a lot of Spack's infrastructure. It'd be really cool to work towards having these separated from Spack instead of built into Spack to allow tools that build off of these libraries to update more easily and not need to like take all of Spack to update. Yeah. I think I already talked about this, but one kind of neat thing that I don't know how many people have done so far to point out is that Spack's infrastructure can be used for more than just Spack. You can build other tools off of it and do some kind of neat things with it. That's all I've got. Any questions?
Thank you. Questions? So I guess I have one. When you looked at designing Ramble and kind of picking out, like, what did I like from Spack, how did that decision process go in terms of what were we going to take out as a common feature from Spack versus what are the things that we consider too package manager specific?
I think when we were trying to make these decisions, a lot of the time it was, so the DSL was probably the first thing. It was like, cool, we want to make this description of applications that describe where input files are and what the output looks like. That kind of maps nicely to package definitions. Some of the actual build system logic in Spack doesn't apply to us that well, and so we kind of ignore that entirely. And then we intentionally make a choice to look for functionality in Spack that maps nicely to something that we want to do, so we don't have to re-implement it. I think that the hierarchy of configuration scopes in Spack is really cool and something that we use a lot. We have to layer on something else beyond that just because of how we describe these experiments and how it doesn't map nicely to Spack's hierarchy of configuration scopes. And then the repository for storing these packages was really cool. We had to extend it as well because we have a lot more object types that we want to track than just packages that Spack does right now. And so at some point, like trying to match those together might be some effort, but outside of that, it's basically just we have something we want to do. Is there something in Spack that we can leverage to do this so we don't have to re-implement it ourselves?
Very cool. Thank you. So we have a question over here.
Yeah, so I think all the functionality you can provide in like a small amount of domain-specific code is really cool. And the experimental side kind of reminds me a lot of like workflow languages, like the common workflow languages and other things. And it doesn't seem like you go really deep into the application code side of it, but where do you see kind of the synergy or the advantages of using one or the other? Like is it, do you think there's, because what the workflow languages allow you to do is kind of swap out a backend, I guess. And so, do you see some way of maybe connecting that or?
Yeah, I mean, I think that if workflow languages are something that we want to adopt, we could imagine adding that in as part of the abstraction. I think that I don't have a lot of experience with workflow languages, but I don't know that they currently track a lot of the things that we want to track. Yeah.
Right. Yeah. No, I can definitely see that from the reproducibility point of view. This is kind of like a stronger representation.
Yeah.
Are there dependencies among jobs in Ramble? Because I mean, that's the main thing that a lot of the workflow languages provide. And it seems like you guys are providing like a way to describe scaling studies and different inputs for jobs and things like that, but not necessarily dependencies. Is that accurate?
Not dependencies specifically. We have talked multiple times about trying to add that, but haven't come up with a concrete use case that we need to do that. One thing that we do have is so you could imagine running something like an MPI micro-benchmark as a health check of a system before you run your actual job, if that's something you want to do. So we have a concept, which I'm not going to go through in slides because it's pretty complicated, of chained experiments where you can describe a like template Intel MPI benchmark or OMB benchmark, and then replicate it inside the context of all of the other experiments. And so it will build that hierarchy of them.
So like setup.
What?
Like setup.
Yeah.
Yeah, setup code for like a test.
Yeah.
Cool.
All right, any other questions? Okay, let's thank the speaker.